All right. Well, just want to say thank you for everyone joining us again for our last and final session here. We have Craig. He's going to give a great talk here on compost, and I'm looking forward to it. So with that, I'll give it to you, Craig.
Thank you, Danny. Welcome, everybody. I think it's a fairly small group this afternoon, but I specifically picked it for noon during lunch hour because we're going to be talking a lot about how compost nutrients, how they are generated and how they move through the soil. And it has a lot to do with the soil food web, which is really the trophic level of what eats what in the soil. So we're going to get to that shortly, but let me tell you a little bit about myself and my background. I work for Squall Valley Soils as their sustainability manager, also handle business development. And my background, my doctorate, master's and doctorate were in plant pathology, which in California particularly, because we're in a semi-arid environment, majority of the big diseases that attack plants have to do with soil-borne organisms. And so I had a thorough grounding at University of California, Riverside in soil bacteriology, mycology, study of fungi, virology, and my main focus was nematology, parasitic roundworms that inhabit all of our soils, and in fact are the most plentiful organism. And we're gonna take a look at just what's going on in the soil in terms of biology that most people just honestly don't know about. So let's get started. First of all, Squall Valley. So I thought I'd tell you a little bit about this company because it exists we're a composting operation, but we sell other types of aggregates and other forms of organics to assist the landscape industry and the horticultural industry, organic farmers. It's situated in the Squall Valley Agricultural Preserve, which is probably the most significant remaining agricultural site and owned by the city of San Diego, even though it's located in the city of Escondido. It is about 33,000 acre watershed, 14,000 of which are in the ag preserve. And the city of San Diego owns this to protect the groundwater quality that serves the population of San Diego. And we are a major player, Squall Valley Soils, and we are connected to Frank Conine Dairy that has been there since 1962. And to give you an idea of how agriculture has changed in San Diego County, at the time the dairy was established, there were 250 dairies in San Diego. Today, there are 2 left. This is the largest. We have about 2,000 head of cattle, and here they are. And they contribute and give us the opportunity to offer the only manure-based compost available, OMRI approved for the organic growing industry in San Diego. San Diego County has a very large, active small farm program throughout the county. A lot of small farms. One of the most prolific small farm areas in the United States, and we're able to offer them composted dairy manure blended in with some of our yard trimming what I call feedstocks, to produce a really high quality compost, along with other products that go into our stormwater blankets, soil regeneration, and what have you. So rather than talk about the products of today, we're going to talk about how these products behave, and particularly the finer material. We are members of the Association of Compost Producers, and as such, I am also on the board of directors for this organization. And their whole purpose, they are the chapter, California state chapter for the U.S. Composting Council. They're a 501c organization, and their whole focus is to support beneficial reuse of organics. And why is that important? It's because the state of California, in its wisdom, wants to divert organics away from landfills where they produce short-lived greenhouse gases like methane and start to repurpose them to develop sustainable, healthy soils. Well, one of the biggest challenges we have with compost are some of the myths associated with its use and as it relates to stormwater runoff. And one of the first myths that we're going to talk about is compost is an organic fertilizer used as an alternative to synthetic fertilizers. The common perception is, and it's correct, compost is good for soil, in part because it adds nutrients for plants. But what people do is they take that further and go, well, then it must be a fertilizer. It certainly sounds like a fertilizer. Well, the facts are, the legal definition of a fertilizer is typically a soil amendment that guarantees the minimum percentages of nutrients available in a product. So when you look at a bag of fertilizer, you'll see percent NPK. This is the minimum percentages that that product will deliver to the soil in an inorganic form. It's not complex. It may be ammonium sulfate. It may be a nitrate material or what have you. It'll have different variations of inorganic fertilizers present. Compost, however, can't legally typically be labeled as a fertilizer because in its very nature, it is impossible to guarantee a minimum percentage of readily available nutrients from batch to batch. In addition, when you go that further, the nutrients in compost are perceived to be as leachable as any other nutrient, and so therefore will leach out during a rain event and contribute to stormwater runoff pollution. And we hear that all the time. We're not going to use compost near a body of water because it's going to leach out. Well, again, leaching, let's just describe what we're talking about there. That's the washing out of the soluble ions, and I emphasize soluble, and the compound and other compounds by water draining through that soil, and in this case, through the compost. Well, the facts are that most commercially available compost is a very poor source of immediately available nutrients, and as such, contributes very little to nothing in the way of nutrients to stormwater runoff. So typically, if you evaluate compost, you'll see that it has a NPK, some of your macronutrients, of 1 to 5%, very, very low, versus, let's say, a bag of fertilizer having somewhere around 20, sometimes even higher, 20% nitrogen and higher levels of phosphorus and potassium. So a third myth that we're going to move into, and then we're going to start talking about how compost does behave. But the nutrients, the thought is, well, hey, nitrogen is nitrogen, phosphorus is phosphorus, nutrients are nutrients, and there's no difference between an inorganic and organic form as they relate to leachability. That's kind of something most people don't give a lot of thought to, while in fact, organic nutrients are compounds that had their origin in living material and therefore are still part of a carbon chain complex. And the emphasis is on carbon, and we're going to talk about that carbon cycle and how important that is. They are not available for plant uptake until microorganisms transform them into a usable form. So synthetic water-soluble inorganic forms that we typically think of as fertilizers and nutrients are typically designed to be readily available to plants, and often, because they are so readily available, are applied in excess, resulting in leaching and contamination of stormwater runoff. In short, it's oftentimes too much of a good thing. That's why we have nitrate contamination of our groundwater, and that's why most of us drink bottled water in some form or another, because of this leachability of these synthetic fertilizers that have been used extensively throughout our environment for many, many decades. The last myth I want to talk about is compost provides nutrients to plants. You would think that seems to make common sense, doesn't it? But actuality is, the fact is, compost feeds and supports the microbiome in the soil, which then in turn feeds the plant. And that's called the soil food web. So before I move into that topic, I'd like to just say, when can recycled organics become a problem in stormwater? And it's when you have either a poor quality, non-certified, immature compost or recycled organic. And oftentimes the feedstock in this case is very important. If you have manure, I would not use a manure-based compost if I'm concerned with absorbing stormwater, because that has a higher nutrient value, and I'm going to use that more like a fertilizer. Where we get into problems with recycled organics, and I like to call it immature compost or other feedstock that's organic in nature, is when it's applied and exposed to waterlogged, saturated conditions in soils over a prolonged period of time. Poor drainage, standing water, soil that's tied up and tight and doesn't drain well leads to anaerobic soil conditions, and it leads to an actual extraction of these nutrients that are present in the organic matter into the soil water. Typically, in a healthy stormwater management environment, you want the water to be flowing. You don't want stagnant water. You want it to be infiltrating. You want that water to be moving and be filtered. That is not the case where you have stagnant standing water. So now I'm going to go into compost general definition and why most people believe it is a fertilizer, because if you go to the Merriam-Webster dictionary, it says it's a mixture that consists largely of decayed organic matter, and it's used for fertilizing and conditioning land. That's the general definition in the dictionary. But if you actually look at a more detailed understanding of compost, you'll find it's a heat-dependent, controlled microbial process of decomposition and recycling of organic material into a stable and humus-rich material known as compost. And some of the feedstocks are yard trimmings, organic food and agricultural waste, animal manures, and such. This organic material must consist of principally organic components, that is, carbon-containing remnants or residue of live processes. That changes the entire game. We're no longer looking at an inorganic form of nitrogen, phosphorus, and what have you. We're looking at these complexes. The feedstock material is very critical because some of the feedstock contains higher levels of nutrients, some lower, some less decomposed and less available, like wood chips, or like compost that's been degraded and stabilized and has high levels of other nutrients, and particularly humus. And we're going to talk about humus in just a second. And then we've got the whole area of the compost that we produce. And it's the solid waste that we dispose of every day into the millions of tons a day. And that is processed into municipal solid waste and then oftentimes blended in with other compost to produce products that can be reapplied to the land to nourish crops. So you have this whole wide spectrum. Compost is not compost in that there are all kinds. It's a very general term, and not all composts are created equal. In fact, just the opposite. So in California, the definition of compost is a product resulting from the controlled biological decomposition of organic matter. This comes from Cal Recycle's website. It's specifically a very stable, humus-like product resulting from the biological decomposition of the organic matter under very controlled conditions. Thus the term composting. What's this humus we're talking about? Well, that's that dark organic matter that forms in soil when dead plants and animal matter are thoroughly degraded, completely stabilized, specifically through the action of anaerobic organisms. So compost is typically produced in an aerobic environment, but in that process, there's some anaerobic fermentation going on that produces this extremely stable product or material called humus. Humus has the ability to be very insoluble, very effective at water holding capacity, extremely high cation exchange capacity, meaning it holds these positive charges, and therefore with water being positive, a negatively charged, that cation exchange capacity will be very, very beneficial in holding water. It holds nutrients extremely well and provides them to soil microbes. It improves the aggregation and soil particles in terms of the soil structure, or what is commonly referred to as soil tilth. So that enhances the air, water, and et cetera, the infiltration and the ability of that soil to do what we need it to do to survive and support the population of living systems around the planet. This chart was recently published. You can see August of 2020 in the Biocycle Connection, which is a leading website for people interested in handling organics, recycled organics. Ron Alexander published this article, Compost and Humic Substances, And he did his own study and evaluated humus is typically made up of humic acid, fulvic acid, and humin. These are various components of this material that's produced. And if you look at, for example, the harvest blend compost from Engel and Gray, about 3 down, you'll see that 5.2% of the compost consists of this humus. And that's coming from yard trimmings, byproducts, biosolids, wood chips, etc., that Engel and Gray use to make a high quality compost. And what they did, what Ron Alexander discovered is that the longer the compost cures, the higher the level of these humic substances in that. And therefore, why is that important? Because compost, in containing these humic substances, they're a very stable form of organic matter and are important components of health, all healthy soils. In fact, there's a very strong correlation between compost stability and humus and the CEC, cation exchange capacity of the compost. That means that because it has that high activity of cation exchange, it grabs a hold of a lot of pollutants and nutrients, and it becomes an extremely important component of the soil. So compost, first and foremost, is biologically active. Other nutrients like inorganic nitrate, nitrogen, ammoniacal food is not biologically active. It's used by biological organisms in a very controlled manner. Microbial stability is the prerequisite to compost maturity. Since stabilized compost is no longer subject to these sudden chemical changes, it can be safely handled, stored, and applied. Immature compost, and we talked about that earlier, can rob plant roots of oxygen and nitrogen as it breaks down further, in addition to stunting plant growth by introducing harmful and leachable materials, which have not been fully decomposed and integrated into the soil structure. This way of measuring maturity of compost deals with the carbon-nitrogen ratio. That's what we look at. Carbon is the most abundant element in compost. Nitrogen is present usually in a 1 to 2% of that compost. So a CNN, carbon to nitrogen ratio, is the common index used for assessing the feedstock and the maturity of compost, so we can evaluate its quality and its suitability for use. The carbon nitrogen ratio in a typical finished compost should range between 12 to 1 to 20 to 1, ideally about 14 to 1 to 18 to 1. That's where you want it to be. If it's too low, it's going to have too much nitrogen. That's the microbes are going to, you're going to stimulate microbial activity at the expense of humic and humus formation. If it's too high and it has too much carbon in it, it will shut down the biology in the soil and slow the entire availability of nutrients to plants. So this range is really critical. This is what we're looking for. This is why we evaluate compost. And it has everything to do with the way carbon is cycled in our environment. It is the most misunderstood, unappreciated life support element we have. Here's an example, a very simple schematic diagram, I should say, of the carbon cycle. Carbon comes from the air, the carbon dioxide, the methane, all the other forms of carbon that are floating around the environment. It's grabbed a hold of through the photosynthetic process in plants, and it's captured and sequestered in that plant material. It is eventually cycled down into the soil where the plant root system sloughs off, the leaves drop, they produce their own compost, and this becomes a part of the soil biome that is feeding the biology of the soil. You also have carbon being respired back up into the air where it's captured again by plant materials. So you have this entire cycle going on, and it's much more complex than this, but just to give you an idea, by mass, this carbon is the most abundant constituent of all major molecules that living organisms are formed from, including our nucleic acid, our DNA, proteins, carbohydrates, and lipids. In short, as a result, living organisms are intimately involved and dependent on the carbon cycle, and yet we pay very little attention to it as it relates to our soils. Organic carbon in soil organisms. Compost contains approximately 50% organic matter by weight. That organic matter is made of carbon compounds, decomposed plant, animal, and microbial matter. So this carbon provides the energy to the soil microbes, to the organisms in the soil. It provides the tilth by adding to the structure of the soil. Now, I will say that the structure of the soil also is very dependent on inorganic compounds that are made available through the decomposition process. It's the inorganic fraction in the soil that creates the structure for the biology to work. So you need, when people say I'm organic, they're actually saying they're both organic and inorganic. We can't have one without the other. You cannot have an active living soil just with organic carbon. You need all the other components to make it work. And we must keep adding. This is something that is, as you can see, the CO2 is given off. And when we harvest a crop or cut our grass or take landscape trimmings, we are removing some of that carbon from the soil that's been translocated up, and we have to replenish it. That's called regeneration or regenerative agriculture, or restoring. There's a law of return in all living systems. In natural systems, no such thing as waste exists. Energy and matter are captured by life processes, and you're going to see just how many of these processes there are. And they're released upon the breakdown of this material, only to be reutilized, recycled by the living organisms within our system. This transformation and flow of nutrients containing chemical compounds involved in this process is often referred to as nutrient cycling. Now we're getting into the meat of the topic here, the soil food web. This is where nature, in working with nature, comes in so handy. When we start to understand the role of nature in cycling nutrients in our environment, and particularly in the soil, we start to capture the power of biology and the tremendous potential of compost. The soil food web is a series of these organisms linked and cross-linked to each other by who eats whom in and on the soil, creating a web of food chains. There are many, what they'll often call them trophic levels, and we're not going to get too deep into the woods here, but there are many different types of food webs based on each soil environment, and each with a different set of organisms. So what food you produce or provide a soil will dictate what organisms are eating there and living off of each other. And cycling that nutritional value. We know more about the movement of celestial bodies than about the soil underfoot. That was Leonardo da Vinci in the 1500s. More recently, I thought this analogy by Dr. Andrew Moldenke out of Oregon State. Every time you take a step in the mature Oregon forest, your foot is being supported on the backs of 16,000 invertebrates, held up by an average total of 120,000 legs. That's per footstep. Maybe now you're getting a visual picture of just what we're really dealing with when we walk on this earth. And how many organisms are we talking about? Well, there are more microbes in a teaspoon of soil than there are people on the planet Earth. Soil contains about this is per acre foot, 2 to 3 tons of bacteria, fungi, protozoa, nematodes, earthworms, and arthropods per acre foot of soil. Now, I'm talking about a soil that's rich in organic matter that's feeding this biology. Unfortunately, as we rob the soils of organic matter and the food that these organisms depend on, that level goes way down to our detriment. So why should we care about this? Well, by employing the soil food web science, you can reduce and at best eliminate the need for fertilizers, or certainly reduce it, like I said, herbicides, fungicides, and pesticides. Organisms in the soil food web will do most of the work of maintaining soil and plant health. And what tools do we have to enrich and feed these microbes? Well, these are the two big ones that deal with stormwater. The one on the left, the filter media, is designed for filtering. It's the way nature, and it truly is a compost. It just has a larger particle size. It's what we call in the compost industry the overs that we screen out to get the finer material on the right, the growing media, which is designed in what we would use for a stormwater blanket to absorb water, to infiltrate that water, to prevent stormwater runoff, and in the process, minimize pollution. And it also obviously supports plant growth. We can use both of these in varying ratios to accomplish different things. The compost provides three-way biofiltration. It's a physical matrix that traps sediment in varying pore spaces and sizes. And it also chemically binds and adsorbs pollutants in stormwater. And biologically, not only does it capture and hold these pollutants, but things like hydrocarbons and what have you are degraded through the bacteria and fungi in the soil and literally are rendered harmless. We can put the coarse material in socks and use it to filter stormwater in place where we have a concentrated flow and we don't want the compost blown down the street. So that's why compost socks became so popular. It was a way of simply moving a berm, if you will, of the coarse filter media into the path of the flowing water, removing the sediment, capturing the pollutants, and also, in many cases, creating sheet flow so that the blanket, the finer material, didn't wash away. When we work with compost, we're trying to mimic nature through natural stormwater management, and we're trying to mimic this environment right here. And you'll notice on the very surface, all of nature is producing a layer of organic matter and creating at that interface between the topsoil and the organic matter a layer of compost. And that compost is feeding in that big circle there, feeding all of that biology, all that soil food web. That's really, really critical. And we can use this material, as they show here, to mimic and recreate, if you will, an environment and landscape that dissipates the energy of the rain impact, similar to what nature would do, hold and infiltrate and evaporate the water, minimize that evaporation, grab a hold of the water, infiltrate it, store it so we don't lose that valuable resource, slow it down and disperse the energy of that sheet flow, and provide for optimum vegetative growth, which is by far the best stormwater management we can get. When we look at nitrates and phosphate, two of the bigger macronutrients in the environment, the research supports the fact that a good quality compost, one that is not in a leachable form, that's really stabilized, been tested, not only doesn't contribute to nitrogen, it actually reduces the nitrate and the phosphate loads in soils. This is work done by three researchers, four reports. Dr. Fawcett of Filtrex International did his thesis on it at the University of Georgia. And note here, these are all the reductions in pollutant loads from using a compost blanket. Here it's bouncing around. Also, the blankets and the filter media are extremely effective in not only sediment control, nitrogen, nitrate and ammoniacal reduction, phosphorus, particularly soluble phosphorus, but also in reducing and capturing E. coli and total coliform bacteria, heavy metals from 37 to 78%, and very, very effective on hydrocarbons, which will actually capture and break down into CO2 and water. So this is all replicated science. It's all reported in scientific journals. If anybody wants, I can provide you all the scientific research papers you want to read to document that this does actually occur. Turbidity, give an example of straw versus polyacrylamide material in a average 4-inch storm event using this fine material. The compost coarse material reduced the turbidity by 35 times lower than just straw and polyacrylamide. And on the compost fine material and blanket, 4.5 times reduction. The reason why you get a little slower flow through the finer material, again, we're using that for infiltration, volume reduction of the stormwater runoff. The coarse material, the coarser we get, the better flow through we have and the better removal efficiency we have with sediment because of the physical trapping characteristics of the coarser material. Now, when we look at the finer materials in a compost blanket, look at the difference between a bare soil at little over 50% and an 84% rainfall absorption in a 4-inch rain event. Is that important in a drought-challenged environment like California? Absolutely. We want to capture all the water we can and infiltrate it as much as we can. This is the value of that material. A recent literature review by CalRecycle looking at the water savings by application types for compost showed that on an average, the maximum water saving was around 46%. And that was from 104 studies. Average minimum water savings, minimum was 20%. And yet we see people consistently not utilizing this very valuable resource. Not only does it capture and absorb water and infiltrate it, but compost is used oftentimes, and these are all examples of compost in a sock to stabilize banks along streams and to make sure that the erosive effects of a flowing stormwater surge doesn't tear into and remove all that valuable topsoil downstream. So they actually use it. They'll actually live stake it oftentimes and jam a stake into the compost sock and vegetate it. They'll use it, oftentimes put seed in the compost sock and vegetate the sock, creating a berm to slow the sock down, slow the flow of water down, and then infiltrate it into the blanket. So in this case, they're using the sock to dissipate the energy as well as a blanket to infiltrate. So it is, because of the research used widely, it is not something, if it's a good quality compost, that you should be nervous about. And the state that has taken this to a new level is the state of Washington, where it rains on a regular basis, temperate rainforest in Washington. They were losing their salmon in the streams due to contaminants coming off of impervious surfaces and urban environments. I'm not going to go into this because there's so much, but please write down soilsforsalmon.org and go to it. They now mandate that compost be a part of every stormwater management program because of its effectiveness in capturing these pollutants and restoring and regenerating the salmon population. This one here on the bottom, the Mid-Klamath Watershed Council program, gives a great example of the use of compost blankets and socks to protect the watershed and to recover the food sheds. Again, the microbiology and removal of contaminants to feed these salmon and create an environment in which they can thrive. I just cite this. We're not going to go into it. It would be an entire a presentation alone on what a tremendous job the state of Washington's done. And it's an example for the entire United States on how to use recycled organics to clean up the environment and to regenerate the population of fish in our streams. So a healthy soil food web, let's review what that'll do for us. It'll retain nutrients. It'll reduce that runoff and that leaching. It'll suppress the diseases associated with unstable soils that are poor in biology. And it does that through competition. Most plant pathological organisms love a vacuum, a biological vacuum. So the more biodiversity I have in a soil environment, the less disease I have because they outcompete the disease organisms for the available organic nutrients available. It'll inhibit, they produce some of these biological organisms will, the discovery of antibiotics was a result of the inhibition of bacteria due to fungi. And the soils are rich with fungi. It'll oftentimes feed parasitic nematodes that will literally eat other nematodes. And it'll increase the nutrient availability at rates optimal for improved plant, not only nutritional quality, but the flavor and the nutrients available for the plants are released in a rich soil food web. It'll decompose toxins, as I talked about earlier. The bacteria will literally use some of these contaminants as a food source. And it'll build that soil structure, reducing water usage, increasing the water holding capacity, and opening up the soil and increasing root depth. So with that said, if we pay attention to the use of organics and specifically compost as a tool for enlivening and feeding the soil food web, we can create healthy food and happy families, that we can grow gardens with good soil, and even more importantly, that good soil will sustain the future quality of life for that young girl there in that slide, our children and that's the true definition of sustainability. It's one thing to sustain something, but what are we sustaining? If we are sustaining a system of working with our environment that does not improve and regenerate and increase the health of the environment, then we're sustaining a toxic environment, not a healthy one. And so that's the message I want to leave with you. This is my contact information. I will say that if you go to spvsoils.com, I just started a new blog called Dr. K's Corner, where every few weeks to a month, I'm going to be talking about different topics and sharing with you different ways that compost and recycled organics can enhance the quality of our environment, manage our stormwater, grow healthier food, and most importantly, feed all those microbes that we're stepping on every day that we essentially depend upon for our very survival, and certainly that the plants depend on to be healthy. So please contact me directly if you have any questions, and I'll open it up right now to any questions from the listeners, Dan. Or
Great. So we actually have about 4 here in the chat. I'll read them as they came in. First one here says, if compost is so great at capturing pollutants such as metals, hydrocarbons, etc., is there no fear of pollutants accumulating in the soil over time or polluting the groundwater?
It depends on the pollutant you're talking about. If the pollutant is of an organic nature, for example, if we have a soil rich in organic matter and biology, hydrocarbon contamination becomes a much less of a concern. And of course, toxins always have to do not only with the presence of a contaminant, but the level at which the contamination exists, meaning you can overwhelm even a living system. For example, raw, highly available nitrogen will actually damage the soil biology because it's a salt in its basic form. And as a salt, if we put too much on and we don't buffer that soil with organics and slow that release down a little bit and stabilize it, what happens is the salt actually sucks out the life out of the bacteria and a lot of the life in the soil and will actually destroy the soil life. So it has to do with not only the presence of a contamination, but what the levels are. But in most cases, other than heavy metals, bacteria, hydrocarbons, and nutrients will be recycled through the microbiology, the microbiome in the soil, and rendered not only not a problem, but oftentimes another form of food for the organisms. It'll actually convert it and cycle that material. The heavy metals are a little different. Heavy metals, though, in most cases exist in both a soluble and insoluble form, and we have to be careful with that because as we know, metals, there are, believe it or not, some organisms that will degrade metals, but it'll take a lot longer, and we have to be real careful. So we always suggest, we've never seen a case where we've captured heavy metals in stormwater where we had to deem the compost as a hazardous waste. The levels are usually at very, very low levels, but it does beg the need to replace your filters. If you're capturing something like a heavy metal, replace the organic filter like you would any filter, and then in many cases you can bring that organic material to an incineration site and incinerate it for energy, and the heavy metals will drop out, or you dilute it. That the key is it's the level of contamination so often is what makes something toxic. So you can take the metals and dilute it in by introducing the compost that capture those metals back into a composting process and diluting it over a larger area so it's not a problem. So I hope that answers that question. It really has to do with It's not just a matter. It's funny. I always used to say, even water, the life-sustaining presence of water that we so depend upon for our very survival can be toxic when you have too much of it, because it'll block the imbalance and block the oxygen from getting into the living system, and actually will kill us. So even something as what we consider as benign as water can be toxic in too high levels in the wrong place at the wrong time. So kind of use that as an analogy of how we deal with anything in nature, and it has to do with wrong place at the wrong time and the wrong concentration.
Great. So this next question here, there's two of them. He mentioned a comment that said, please provide, and it says here in quotes, stormwater pollution removal slide documentation info. And then the second part to that was, please elaborate on the compost qualifications for a quality compost.
Good question. I would refer you to the U.S. Composting Council's website, and it's called the Seal of Testing Assurance, STA. And Caltrans requires all compost used on their projects to be STA certified. We are participating in that program, and it requires that you, based on the amount of compost you produce, you test every month on not only the nutrient availability, particle size, but pathogen reduction, weed seed presence, and then the ability for that compost to support the germination of a seedling. And typically it's a cucumber seedling that's very sensitive to salts and what have you. So you want to have your soil, your composted materials tested and verified. Quality and that maturity, that CNN ratio is a big part of the SDA testing program. It's something that you want to ask for. You want to make sure your compost is stable. And then there is a website through CalRecycle that's called the, CalRecycle has a website called the Compost Use Toolbox. Just Google CalRecycle Compost Use Toolbox. It'll bring you to a website where they show, I think it's 12 different ways of using compost to solve environmental problems, and all the research and references on where to get additional information. And then another excellent resource, they're pioneers in the use of compost, is Filtrex.com. Filtrex International publishes on their website at no cost a design manual where they give all the details, specifications, CAD drawings, everything you need to know on how to apply 24 different applications, how to apply compost to solve different problems involving stormwater and landscape management, soil management, including the stormwater blankets, filter socks, biofiltration cells, level spreaders. There's even one called compost, it's called compost grouting. And it's riprap grouting, where they apply a blanket fine compost in between the riprap with seeds, and they vegetate the interspace between the rock to add more additional filtering capability to the riprap to handle finer and soluble pollutants.
Great. And then this next question here says, this question has elements of your previous presentation, but does your company have online demonstrations of how to apply the compost blankets utilizing the mature compost?
I can provide, there are public YouTube videos literally on how to do that. If you'll just email me that request, I will literally navigate the web where I actually have them stored, and I will send you videos on how to apply it, and any other specific questions you have, what's the best way to move forward to help with the design and the installation details on how to use the materials.
This next question here says, so how long will the videos from this seminar be available? So Lisa, all the seminars that we've had for Stormwater Awareness Week will be actually on our Forge YouTube. So if you go to YouTube and you type in Forge Stormwater Awareness Week 2020, you'll see a lot of the videos pop up, and they should be up for, they shouldn't be taken down anytime soon. Also, if you have a hard time finding them, just reach out to us here at WGR Southwest, and you can send us an email or even give us a call, and we'll link you to those. We have a couple questions here still. So we have in a photo showing the compost socks installed in the construction activities, there is one placed in front of the storm drain inlet. Can you discuss the use of this BMP in a non-soil system like this? Physical barrier, filter rates, how is it stabilized on the pavement, etc.?
Excellent question. Thank you. Around inlets, particularly on impervious surfaces, first of all, a compost sock is a weighted BMP in the sense that once it gets saturated with water, it's heavy. A linear foot of 8-inch sock that's got moisture in it is about 13 pounds a linear foot. An 8-inch sock will filter about 7.5 gallons per minute per linear foot. So depending on the length or the width of the diameter of the sock, that will determine how much water that filtering device, that filter sock, can handle. So an 8-inch sock will be 7.5 gallons. A 12-inch sock will handle about, it's about 11.5 gallons per linear foot flow through. But you're going to want to put some weight on that if you have a fairly concentrated flow, because, and even when you don't, one of the critical factors, and WGR will attest to this, is that if you have 98% contact with the impervious surface, but 2% of a gap in there, that water will find that gap, and those pollutants will siphon right through that little gap. So you want to make sure that that sock is got integral contact with the impervious surface you're putting it around an inlet. And one of the ways to do that oftentimes is you can double stack them, or you can do a pyramid stack, 2 on the bottom, 1 on top. And that will definitely fill any of those, minimize any gaps that might form. Or you can add multiple layers or rings around the inlet, almost like phases. I always look at the first ring of a sock around an inlet is phase 1 filtration. A second ring would be phase 2, and the more rings you add, the more phases of filtration you have, because the water has to flow through each one of those filtering devices to get to the inlet. The one thing you do run into, if you put too much filtering devices in front of the inlet, it'll slow that water down so much that you may get excessive ponding, so you have to be careful. One of the ways you can address excessive ponding is you push down on the middle of the sock a little bit to allow it to rise maybe 3-4 inches and then overflow and hit the next sock. So as it goes from one sock to the other, that's the principle of check dams. Check dams typically are lower in the middle. They're there to slow the water down, filter some of it, but spill over to the next check dam. And so you put these in parallel, and they cascade through the flow of the water, removing each filter sock, removing a little bit more of the contaminants and the sediment that you're trying to control. So you're not trying to do everything with one device or one filtering mechanism. You're trying to do it with what we call a treatment train. And WGR has a lot of experience. They've actually got a constructed treatment train where they use filter socks and a blanket to filter stormwater contaminants, and they can demonstrate that for you. I believe it's demonstrated on a video showing that treatment train setup. So that's how I would recommend that it be used around inlets where you really want, your optimum filtration of the contaminants before it's released into the drain inlet.
Great, and we have a couple more questions here. We have rice and straw mulch is often applied on construction sites to protect soils from erosion and to promote new vegetative growth. Is this quote unquote immature compost? Any downside to using mulch versus stabilized compost?
Well, mulch is a very general term that just means anything applied to the surface. It can be everything from rice straw to compost to ground up rubber. I've seen used as a mulch, to gravel. You can have a gravel mulch. So mulch is a very general term. You have to be careful how it's used. A compost blanket is a mulch, a 1 to 2 inch layer of the 1/2 inch minus compost, and does a very good job. Typically, if you apply something like a non-composted material like rice straw or regular straw, what you're going to do is you're not going to have anywhere near the biology, and the microbes at the interface between the soil and the non-decomposed organic matter, like the straw, will start to work to break it down, but it'll take some time. And you're not going to get immediate benefits, but it will work over time. It just doesn't work well. The other thing is that a mulch layer will not rob the soil underneath it of nutrients. So the only time non-composted material starts to take the nitrogen away from the microbes that need that nitrogen to break down the carbon is when you incorporate it into the soil and then you plant into it. I've actually seen situations where an uncomposted material is incorporated in, people plant into it, and the plant starves from nitrogen, because the rule of thumb in soil ecology is the microbes always eat first, meaning they will always take the available nitrogen first to break down the carbon complexes and release the nutrients in the carbon, carbon material. The compost we've already started that process, so it's a lot faster. So I hope that answers the question, that nutrients in the carbon complex are only released through the microbial decomposition process, and a layer of mulch, whether it's decomposed or composted, or non-decomposed or composted, will just basically be either a slow release of nutrients or a more readily available release of nutrients.
Great.
Hope that's clear. I can send, whoever asked that question, if you email me, I can send you more information on that. There's been a lot of research on that by Dr. Jim Downer of the University of California in Ventura, showing that even wood chips on the surface of soil, such as eucalyptus, are actually beneficial to the soil biome and will not rob that soil of its nutritional value. It's only when you incorporate it into the soil that you run into a problem.
Great. The next question here says, does San Pasco Valley Soils have product distributors up here in Northern California?
Unfortunately, we don't. We're a local source material, and that's pretty true of everybody but somebody like a Kellogg's Garden Products, where they bag. They're more of a compost broker, where they mix soil blends and bag them and ship them all over the United States. The reason we don't, and why most composters are local, is because of the high cost of transporting this organic material to the site where it needs to be used. That's why we always encourage people to work with your local composter, because if we're sequestering carbon by the use of compost, but we're transporting it over thousands of miles to get somewhere, are we really having much of a net effect on the carbon in the environment when we have a carbon footprint that's spewing out carbon monoxide and other carbon-based materials into the environment just to get the carbon to where we think it's going to do some good? We're actually shooting ourselves in the foot in that particular case. It's not a sustainable practice, and it's certainly not it can be a regenerative practice, but one that's got a negative consequence.
Awesome. Well, that seems to be the last of the questions there.
I just want to thank everybody for joining. We're just about at the end here. If there are any other questions you have, you can always email me at the email address there, or call me, or better yet, just join the blogs and take advantage of the information I'll be sharing on a regular basis. And by all means, check out some of the resources available online from Cal Recycle. There's some great work done by Dr. David Crone on compost use and water quality. It was published. It's on the Cal Recycle. Dr. David Crone of UCR did a study on regenerating fire-damaged soils. Soils that have experienced a wildfire have a hydrophobic layer on the surface that sheds water, resulting in tremendous problems after a fire when the winter rains come. A 1 to 2 inch blanket on that fire-damaged soil will absorb that water, allow it to infiltrate, stop the impact of that hydrophobic layer, from allowing all of that soil to run off the slope. So that report was an extensive report. It's actually, he summarizes it nicely, but it's about a 150-page research report. It's one of the most definitive studies done. Another one is Caltrans 2-year evaluation. Scott Dolan of District 5. If you want a copy of his presentation on a 2-year evaluation on highly erosive soils and how effective compost was compared to straw wattles and hydromulch, please contact me. I will send you that presentation from Caltrans. It's exceptional. It's the largest scale. 8 acres were treated with compost, and the results were just truthfully amazing, what results they got with it. So I think it's the biggest definitive field trial I've ever seen, and that was done here in California.
Fantastic. Well, just a couple comments here. Just everyone's just thanking you for such an informative workshop, which I could agree. Thank you so much, Craig, for your time. I think you've done a total of 3 with WGR this week, I believe.
Two of them were a repeat on the blankets because I'm a big fan of compost stormwater blankets, because they do everything we're talking about here. They're going to feed that biome in a way, and you just get so many more environmental benefits from a blanket of compost than you do any other BMP that I'm aware of. And I challenge anybody out there to prove me wrong on that, because there's years of research documenting what I'm telling you.
Well, thank you so much. It was a great Zoom session. So, and I just also want to thank all the participants for coming this week. This is our last call, but all the videos, as I said, will be up on YouTube. They'll be up on our Forge website as well. So you can rewatch this as much as you'd like. You could even share this with others, maybe use it as a form of training. But this is a wrap for Stormwater Awareness Week 2020. You know, we didn't know what to expect coming into this live format. And the amount of participants that we got this week blew our expectations out of the water. I believe, I don't know what the official tally is, but from what I heard from the Waterworks, it's over 1,000 people has participated in this week, which is insane. So thank you so much for your time, Craig. Thank you for everyone who joined us this week, and we look forward to next year. So you folks have a great afternoon. Thank you.
And thanks everybody for tuning in. Have a good day.